All right, so this next one, we're supposed to determine whether the data represent direct variation, inverse variation, or neither. If the data represent either direct variation or inverse, find the equation that models the data. Then graph the equation if it exists along with the data points given. Okay, so first off, we have our data points. So let's go ahead and we can graph this by hand. So we'll go 1, 2, 3, 4, 5, 6. And we'll go 1, 2, 3, 4, 5. So we'll go 1, 2, 3, 4, 5, 6, 5, 10, 15, 20. And so at 3, it's 7.5. So that's somewhere about here. 4 is about 10, so it's a little higher. 5 is 12.5, so it's a little bit higher. And 6 is at 15, so it's just a little bit higher. So to me, it looks like it's a direct variation. It's just a straight line. Okay. So I'm going to say direct. So now what we need to do is we need to make an equation of the line. So I'm going to choose 2 points. I'm just going to say, let's choose this point and this point. Then I don't have to work with the decimals. So first we need to find the slope. And remember, slope is the change in y over the change in x. So I'm going to take the y, 15, minus 10. So I'm going to take 15 minus 10 over, now I'm going to take 6 minus 4. And so 15 minus 10 is 5, 6 minus 4 is 2, so that's my slope. Now I'm going to use the slope-intercept form, so y equals, oops, not y equals, y minus. Y minus y1 equals x, or m, times x minus x1. So y1, let's use this one. Tens are easy to work with. So we're going to say y minus 10 equals our slope 5 halves times x minus 4. Now I have to distribute here. So y minus 10 equals 5 halves x. And then 2 going here too, so that's going to be a minus 10. Now I add 10. So y equals basically just 5 halves x because those cancel. All right, so that's my equation of the line. So that would be the equation. So we found the equation, we've graphed it, and we've plotted the points, and so that's what it was. Now let's see if we have something similar if we used our calculator. So what we're going to do is we're going to go to our calculator, we're going to go to stat, and we're going to go to edit, so we'll do number 1. Now we need to clear out what's in there. So if we arrow up to L1, hit clear, arrow down, arrow over, arrow up. On L2, hit clear, arrow down. Now we can type in L1 is X, L2 is Y. So our X's were 3, 4, 5, 6, and our Y's were 7.5, 10, 12.5, and 15. All right, so now we've got our data in. Now we're going to go hit stat again. And since we said it was direct, that means it's going to be a linear regression. So we're going to go over to calc and we're going to do linear regression, which is number 4. Now we have to make sure our list x is L1. Now here, L3 is not our y. So we have to go second 2 to make that L1 is x, L2 is y. And then we're going to store our equation. And so now we're going to go to vars. We're going to go over to yvars. We're going to do 1 for function, and we're going to store it in y1. So we'll hit 1 again. Then we hit enter, and now we hit calculate, so we hit enter again. And it shows us our equation is y equals 2.5x plus 0. Well, 2.5 is the same thing as 5 halves, which is what we found, so that's good. So now let's go and see what it looks like plotted. So let's go up here. Let's turn stat plot on, because if we have it on, it'll plot the points, and that's kind of one of the things they wanted us to do. And let's check our window. Yeah, that looks okay. And so this is what our equation looks like for the line. These are our actual points on the line, and so that's overall what it is. And so that's going to be our thing. Now, if we go back up to y here, it puts the actual equation here that it found for us here. So if we forgot to write it down and we stored it in y1 or wherever we stored it in y1, y2, or whatever, it'll actually show up here, and then we can write it down later. So that'll help you on something like that. So again, we did it by hand, but here it's also on the calculator. All right, so let's go back over here and let's go ahead and stop here and we'll come back for some more.